Okay, let's start chapter 3 together. It's about intro to organic molecules and functional groups. So you're one step closer to the real organic chemistry. What we had so far was just an introduction and review on general chemistry 1 and 2 mainly, a little bit of organic chemistry, and now we are getting deeper in organic concepts. The first thing we need to know is the difference between hydrocarbons and functional groups. So let's see what are hydrocarbons. As their name says, they are composed of hydrogen and carbon only, and they can be straight chain that we call them aliphatic. So get used to these terms. Aliphatic hydrocarbons are straight chains. They can be saturated or unsaturated. When we say saturated, means all single bonds like alkanes. And they can be unsaturated like double and triple bonds also like alkenes and alkynes. So an alkane, you remember that the simplest example was a methane molecule. Just carbon and hydrogens, all single bonds. An example of alkene, you can say the simplest alkene, ethene. And the simplest alkyne, you can say ethine or acetylene with triple bonds. So these are all called aliphatic hydrocarbons, a straight chain. And the other category of hydrocarbons are called aromatic. Aromatic compounds are cyclic, like benzene. You will learn more about these, especially in organic too. Aromatic, the name says aromatic, aroma. Aroma means odor, means a smell, and not necessarily a good smell, but aromatic compounds all have a smell. So this is the definition for hydrocarbons. They can be straight chain, they can be cyclic, and the straight chain can be saturated or unsaturated, and aromatic compounds are always cyclic. Now, if our molecule has other atoms other than carbon and hydrogen, like oxygen, like sulfur, nitrogen, halogens, then we have functional groups in our molecule. Like, for example, we have CH3, CH2, and OH. And we all know that this is an alcohol, ethanol, drinking alcohol. So, if a molecule has another atom other than carbon and hydrogen in it, it definitely has a functional group. Other atoms can be oxygen, sulfur, nitrogen, and halogens, not other atoms. So we are lucky here. We are not talking about the whole periodic table of elements. We're just talking about these atoms in the organic compounds connected to carbon and oxygen. So as the name explains, functional group, the function of the molecule depends on what we see here, what we have connected to carbons. So we will talk about each functional group. We will introduce each functional group, don't worry. But let's work on some of the examples on page 1 of this study guide. We are supposed to draw an alkane. I drew an alkane for you. Feel free to draw any other alkanes you want. I drew an alkene for you. I drew an alkyne for you. And I drew an aromatic compound for you. So that's the example, the practice on page 1. Before we get to classification of carbons, the next thing you need to know for organic molecules. In organic molecules, we have different types of carbons, and it's extremely important to know what type of carbon we are dealing with. This is like the alphabets of organic chemistry. So I draw the same exact format we have on the study guides to help you understand it better. Okay. Now, let's study them one by one. The central carbon here is connected to one more carbon. Please pay attention. I'm just mentioning the number of carbons attached. So, if a carbon is attached to just one more carbon, we call it a primary carbon. And instead of writing the whole word primary, we just put number 1 and a degree symbol on the upper right side. So this is a sign, this is a symbol for primary. You can skip writing it and then just show it with the sign. If the carbon is connected to 2 more carbons, we call it a secondary carbon, and we show it with a 2 and a degree symbol. If it's connected to 3, oops, I forgot to put the 3rd carbon. If it's connected to 3 more carbons, then it's called a tertiary, comes from 3. Tertiary carbon, and we show it with this letter, this symbol. And if it's quaternary, it's connected to 4 more carbons, so we show it. These are the types of the carbons we have in the compounds. We don't have more than that. So, for example, the question on page 1, the last question says, draw a hydrocarbon that contains only primary carbons. Only primary carbons, I would say, just to give you an idea of how to deal with this type of questions, this ethane. So you see each of these carbons is just connected to 1 more carbon. So each of them is a primary carbon. That's how you answer this question. Or the second one is another compound with primary and tertiary. With primary and tertiary. So how about having this compound? Can I say each of these carbons are connected only to directly to 1 more carbon? This carbon to 1 more carbon, so this is primary. This carbon to 1 more carbon, so this is primary also. And this carbon to 1 more carbon, so it is primary. But the central carbon is connected to how many more carbons? 1, 2, 3. That's why it's a tertiary carbon. And I'm sure you can draw the last one, which has secondary and tertiary carbons. So your job here is to determine the type of carbons correctly. Okay, let's move to the next page, keeping these types of carbons still on the board. The practice on page 2 is asking for classifying each sp3 carbon. Sp3 was a hybridization, right? Classifying each sp3 carbon as primary, secondary, tertiary, or quaternary. I'm not going to work on all of them, but let's work on first one. Okay, we have to determine the sp3 carbons first. You remember in the skeletal structure, we do not show the hydrogens. So this carbon should be connected to 3 hydrogens because they're all single bonds. So this is an sp3 carbon. Let's mark the sp3 carbons first. How about this carbon? It's connected to 2 more hydrogens, right? So this is another sp3. The same story for this guy. And the last one also 3 hydrogens, so sp3. Don't forget, each carbon needs 4 bonds around it If you see one bond, the rest of them, or two bonds, the rest of them are hydrogens. If you don't see a double or triple bond. So now let's determine the type of these carbons. The first carbon is how to determine the type of carbon with the number of carbons it's attached to. This carbon is attached to only one more carbon, so this is a primary carbon. The second one is attached to 1 and 2. Don't forget the carbons are at the angles. So it's a secondary carbon. This carbon again connected to 2 more carbons, so secondary again. And this one at the end, always the terminal carbons at the end are primary because they're just connected to 1 more carbon. So that's the first example. If you work on the cyclic compound, to show you how to deal with the cyclic compounds, you can work on the second and the third. I'm sure you can easily determine. This one, let's determine the sp3 carbons first. Seems like all of the carbons are sp3 because they're all single bonded atoms, single bonded carbons. 2 more hydrogens here, 2 more hydrogens, 2 more, 1, 2, 3 bonds, so the last one is hydrogen. Here at the end we also have carbons, right, with 3 hydrogens. Here the same story, here and here, 1, 2, 3, 4, so there is no more hydrogen, but it's still sp3. So in this compound, all of the carbons are sp3, but the types are different. So starting from here on top, the carbon is connected to 2 more carbons, so it's a secondary. Here the same carbon is connected to 2 more. Here the same, 2 more carbons. We don't care about the number of hydrogens, we care about the number of carbons. This carbon here is connected to how many more carbons? 1, 2, and 3. So it's a tertiary carbon. Too big. It's a tertiary carbon. This carbon, 1, 2, 3, and 4. So it's a quaternary carbon. And the carbons at the end, they are connected to 1 more carbon each. So they are primary. All right? So far, all of these carbons had single bonds. So it's time to work on the large compound given. Let's see the difference. If we have a double bond or a single bond, what would be the difference? Okay, now I just wanted to show you that not all the carbons are sp3 carbons. You remember for the hybridization on the carbons, we just count the non-bonding electron pairs and sigma bonds. So if this carbon is connected to oxygen with double bond, one of them is pi and just one of them is sigma. So this carbon, double bonded carbon to anything, to carbon or oxygen, has 3 sigma bonds. So this carbon here is sp2 hybridized, not sp3, because we do not count one of the bonds in double bond. The same story for this carbon, sp2. So if you're supposed to determine the type of carbons of sp3 carbons, you eliminate these and determine the rest of them that are sp3. For example, this carbon here is connected to 3 more carbons and 1 more here, so it's a quaternary carbon. Or this carbon here is connected to 1, 2, 3. Don't say 4 because the 4th one is an OH, so it's just 1, 2, 3. So it's a tertiary carbon, and so on. So now you know how to deal with the types of carbons. The next thing you need to know is the hydrogens, the types of hydrogens, which is very easy. Hydrogens depend on the carbons. So if you have a primary carbon, the hydrogen attached to primary carbon is primary hydrogen. Hydrogen attached to secondary carbon is secondary hydrogen. Hydrogen attached to a tertiary carbon is tertiary hydrogen. And you can imagine for a quaternary carbon, there is no hydrogen, right? Because all the bonds are carbon. So there is no quaternary hydrogen. So the difference between the types of carbons and hydrogens is we have primary hydrogen. We have, you see the carbon is attached to one more carbon. So the hydrogen attached to primary carbon is called primary hydrogen. Here carbon is attached to two more carbons. So the hydrogen is called the secondary. The type of carbon and hydrogen must match. And because this is a tertiary carbon, hydrogen will be a tertiary hydrogen. And for quaternary carbon, there is no hydrogen. We don't have enough space to put any other hydrogens. So we only have 3 types of hydrogens. 4 types of carbons, 3 types of hydrogens. I hope it's clear. Now, if you want to classify each hydrogen on page 2, on this big compound, okay, we're supposed to determine the type of these hydrogens that are labeled. So let's determine the type of carbon they're attached to. This hydrogen is attached to this carbon, and carbon is attached to 2 more carbons. So this is a secondary carbon, so the hydrogen will be a secondary hydrogen. This hydrogen is connected to this carbon, and the carbon is attached to 1, 2, and 3. So this is a tertiary carbon. The hydrogen will be tertiary. The hydrogen here is attached to this carbon, which is attached to 1 more carbon. So it's a primary carbon and primary hydrogen. So without determining the type of carbon, you cannot determine the type of hydrogen. And the last exercise, if we want to work on one of them, let's pick the compound that contains only secondary hydrogens. Only secondary hydrogens will be, I recommend only the cyclic compounds. You see, all of these carbons are attached to 2 more carbons, so they are all secondary carbons. I don't think there are 20, those are secondary. Okay, and so all of these hydrogens are secondary. So you work on the next one, I'm sure you can finish it, the compound that contains only primary and tertiary hydrogens. So you must have primary and tertiary carbons first. All right, so if you notice, we have a table for functional groups. It's time to switch to functional groups. You will have 2 separate chapters about alkenes and alkynes, 3 separate chapters that we will work on those, but let's talk about functional groups. You had them briefly in general chemistry 2. Maybe you did that. So I want you to look at page 4 of the study guide or your textbook or the internet. You can just put organic functional groups and they pop. So I want you to pay attention to what's going on there. I told you functional groups are the combination of carbon and oxygen, carbon and halogen, carbon and nitrogen, and carbon and sulfur. So let's say, for example, if we have alcohol, Then R, you remember I told you R is the combination of carbon and hydrogen. So it can be anything. It can be CH3 as the smallest CH3 or a large group combination of carbon and hydrogens. ROH is alcohol. So I want you to learn it this way. The OH is the functional group. It's called hydroxyl. Hydroxyl. Learn it. OH is called hydroxyl. The only compound that does not have a functional group, you can find it in the table. The only compounds with no functional group are alkanes because they do not have anything but single bonds of carbons and hydrogens. So the only hydrocarbons that don't have the functional groups are alkanes, no functional groups. And you will see that it's so difficult to force them to react because there is no functional group. For the rest of the compounds, because of the existence of functional group, those functional group will react. They're all important. I just work on some of them, but they are all important. Oh, I forgot the acid chloride. Acid chloride. Or let's say, let me work on carboxylic acid first. Carboxylic acid. The formula for a carboxylic acid is RCO double bond OH. So this is a carboxylic acid. If you replace OH with a chlorine atom, you will have acid chloride. You will learn them in organic, do no rush. I mean, we will work on acid chlorides and their reactions. Aldehydes are COH. They're a little bit similar to alcohols, but the difference is in alcohols we have carbon-oxygen single bond, but in aldehydes we have carbon-oxygen double bond. So the way we write it is RCOH, but the way we write the aldehyde is RCHO. Please learn it. RCHO. For alkenes, excuse me, for alkenes, functional group is their double bond. You will see how these double bonds are reactive. As soon as we start working on alkenes, you will see that all the attention, all the reactions is about this double bond. Or for alkynes, is the triple bond, even more reactive than alkenes. For alkyl halides are combination of carbon, hydrogen, and halogen, RX, and X can be especially chlorine and bromine, but it can be fluorine, bromine, and iodine. Also we have amides, amines, anhydrides, aromatic compounds, esters, ethers, ketone, nitrile sulfide, thiol, and thioester. So I want you to work on all of these functional groups, take a look and realize, like digest what's going on, what is in each compound. I don't want you to memorize them by heart at this point because in the coming exam, this functional group table will be given, but not for the rest of the semester and the exams. So one more thing I wanted to tell you about functional groups before we move to the related practices is that I told you that OH is the hydroxyl group, right? Another group or bond that I want you to keep in mind is that, for example, for aldehydes and ketones, like ketone we have RCOR. In general, carbon oxygen double bond is called carbonyl. Carbonyl. So you need to know these names. Carbonyl bond or carbonyl group. Carbon oxygen double bond is called carbonyl. Carbon OH is called hydroxyl. So learn it. Another important thing is that in writing the abbreviation for the alcohols, we have O and H. So we have COH. But in writing the aldehydes, we have RCHO. That's the way we abbreviate it to distinguish the alcohols from aldehydes. And in the actual formula, alcohols have carbon oxygen single bond, aldehydes have carbon oxygen double bond. Now, I would like to go back to the previous page. If I can find it, page 3, to work on some of these functional groups. In each example, I just work on some of them to give you an idea of how to deal with this type of questions. On page 3, the first question is, notice that several functional groups have a carbonyl. Didn't I just tell you about carbonyl? Carbon oxygen double bond. So let's sketch some of them. I told you, ketone, right? RCOR. Or aldehyde. Right? I'm not going to write the rest of them, but I just write the names so you can come up with the examples. How about amides? CON. How about carboxylic acids? COOH. How about esters? COOR. How about thioesters? COSR. And how about the anhydrides? So if you pay attention from page 4, in the structure of all of them, you see a carbon-oxygen double bond. That's the carbonyl. That's question number 1. Question number 2. We're talking about hydroxyl group. Hydroxyl group, remember, I said OH groups. Let's sketch them in the 2 functional groups, hydroxyl OH. The very first thing should come to your mind about hydroxyl is the alcohols. Now go over page 4 and find out the next one. I'm sure you would say carboxylic acid. Can you find hydroxyl in any other functional groups? I'm sure you would say no. In question number 3, we are asking for the functional groups with nitrogen, 3 of them with nitrogen. How about amines or amines, amides? And if you notice that we have different types of amines, we talk about them later, and also nitriles. So you can write nitriles are the compounds with carbon nitrogen triple bond. Amides, they have a carbonyl and nitrogen, and amines just have carbon nitrogen. Nitrogen can have more carbons, and those are the functional groups with nitrogen. In question number 4, we are looking for the functional groups with sulfur atom. with sulfur atom, I'm sure you would say you see it in sulfides. So what is the formula for sulfide? I'm sure you would say in thioesters. You write the formula for thioesters. You can find them on the functional group table. And what is the last one with sulfur? Thiol. So thiol in chemistry refers to sulfur atom. Don't forget the names come from Latin. And if you want to draw and label the functional groups with oxygen that are not hydroxyl or carbonyl, I have one of them for you. If you can find any other thing, say that. Ethers, they have carbon, oxygen, carbon. Like, let's say you would say CH3, or CH3 is an ether. So that's how you work on functional groups. In the next video, we start a brief study on each of the functional groups. But before we finish this, let's work on page 5 and briefly work on, I'm going to work on 2 or 3 of these molecules. The simplest one is nicotine, the smallest, easiest to draw is nicotine. We are supposed to determine its functional groups. So what do you see here? I see the combination of nitrogen and carbon. If you refer to your functional groups, what would you determine? Isn't it an amine or amine? Yeah. How about this group here, the cyclic with double bonds? Would you say it's aromatic? Aromatic compounds are also referred as arenes. If you see any of these, they're the same. Let's work on vanillin. Who doesn't like vanillin in pastry and ice creams? Vanillin, vanilla comes from this. It's the good smell for vanilla. Okay, let's see what we see. Do you see the carbonyl group here? COH. What is COH? I'm sure you will say aldehyde. Let's go down. Do we see the aromatic? Of course we do. Do we see carbon, oxygen, carbon? What is this? Isn't it an ether? And do we see a hydroxyl group? Isn't it an alcohol? So you see how many functional groups exist? 4 functional groups, 4. 4 functional groups exist in the formula of vanillin. Alright, so work on the rest of them and feel free to ask if you have any questions. Study enough because we're going to work on each functional group in the next video.